Well known as the Princess of Hill Stations, Kodaikanal is one of the most famous tourist destinations in the state of Tamil Nadu. Located in the picturesque Palani Hills at a height of 2,300 meters, Kodaikanal has been helping scientists to unravel the mysteries of our sun, as it hosts one of the oldest solar observatory in the world. The Kodaikanal Solar Observatory traces its humble origins as a private observatory initiated by William Petrie, an officer in the East India Company in 1787. The observatory was then passed over to the company and thus took birth, the Madras Observatory. After 115 years of existence, the Madras Observatory was shifted to Kodaikanal. Professor Mitchie Smith undertook the Herculean task of setting up a dedicated solar observatory. Regular observations of the sun began by the early 1900s. White light images of the sun were taken consistently since 1904 using the 6-inch telescope mounted in the North Dome of the observatory. Soon, the interest grew in observing the sun in calcium K and hydrogen alpha spectrum.
This is a spectroheliograph. This is an instrument used to study the sun in monochromatic light. So after the discovery from E. Halley from 1904, this instrument has been here taking the observation of the sun in calcium K as well as H alpha.
John Evershed joined Kodaikanal Solar Observatory in 1907 and used the spectroheliograph to discover that there is a radial outflow of gases from the sunspot. This discovery was later known as the Evershed effect and was a major milestone in the history of the Kodaikanal Solar Observatory. The Kodaikanal Solar Observatory has a rich history of taking solar images in calcium K, hydrogen alpha and white light on photographic plates and films for over a century, making it one of the only place in the world to have such important data set. Every morning, the telescope operator mounts a fresh plate and exposes it to capture the disk of the sun. The plate is further taken to development lab where the negatives are developed using several fixation techniques. These photographic plates and the films containing the solar images have been stored carefully in individual paper envelopes in the archival room, which is maintained at a particular temperature and low humidity conditions for better preservations. Realizing that enormous useful information can be further extracted from the solar archives, efforts were made to digitize the plates and films using state-of-the-art modern instruments. A Digitizer Unit has been set up at the observatory to digitize over 100 years of solar data. The unit consists of a uniform source sphere of 1 meter in diameter with a front mouth opening of about 35 centimeters. The photographic plates from the archival room are carefully taken out, cleaned, and polar aligned corresponding to the date. The plate is then mounted onto the slider, and the overhead CCD camera with a 4K by 4K format that is cryogenically cooled to about minus 100 degrees Celsius is used to take digital images.
Those films or plates, we can't use it in modern day. So it's important that those films or plates are digitized, made it into the electronic form, and those images then can be distributed through the global scientific community, and then we can expect more information on that. So it is very important that all these films or valuable data which is lying can be digitized and made available to others.
Before using the digitized data for scientific analysis, the data is further calibrated. This includes the flat fielding of the raw data, centering the solar disk orienting the north polarity upward and correcting for the photographic density values. Comprehending the importance of the data that could help the scientific community to understand the Sun better, the data is further made freely available on the Institute's website.
This observatory, though it was established very early 1900, over the last 100 years, the telescope or the optical systems have remained unchanged. Many other places, because of modernization, often you dismantle old system and build in new, system. That makes data not compatible. Like if you start collecting the data with a new optical system, that may not be directly comparable with the data collected 50 years back. So, in some sense, Kodaikanal Observatory has not upgraded its old telescope very frequently, but that has enabled this data which we have now digitized and we are looking at is a very uniform quality. So arguably, probably Kodaikanal has the longest and most uniform multiple wavelength observations of the Sun for past century, anywhere in the world.
Over the last several years, the scientists from the Indian Institute of Astrophysics have used this very own data extensively to find new sciences in long-term variation studies of the Sun, and these results have also been published in leading international science journals. Some of the notable results include generating plots using the white light data to capture the cyclic variation of the solar activity and also the migration of sunspots towards the solar equator with the progress of solar cycles. The data has enabled the researchers to produce 100 years of Carrington maps that provided a very useful representation of the overall solar activity. Also, the hydrogen alpha data has helped to extract the century-long activities of the solar filaments. The result has shown that these filaments could well play a key role in determining the next solar cycle activity. With the advent of technology and the shift from analog to digital, it is no longer possible to continue observations using photographic plates and films. Therefore, the observatory has set new telescopes observing in white light, calcium K, and hydrogen alpha, and capturing data in digital formats. This provided some overlap time for cross-calibration between the old and new data taken using a different set of telescopes. The Kodaikanal Solar Observatory also houses the Solar Tunnel Telescope. This tunnel telescope contains a coilostat. The three identical mirrors divert the sunlight into a 60-meter long underground tunnel that passes through a set of lenses to form a 34-centimeter disk image of the Sun. Apart from the archival solar images, the Kodaikanal Solar Observatory's library treasures astronomical literature books and observational records dating as back as 1794. One of the highlighting features of the library is its unique shelf arrangements, which extend all the way to the ceiling of the library hall. As part of the outreach activity, the observatory has also developed a popular astronomy museum within the campus for students and tourists.
This museum explains about the basics of astronomy and astrophysics, as well as what are the facilities available in IAE. As well as since it's a field station meant for solar physics, there is one model here and show how we are taking the sun's image and also atmosphere studies and other things. And now earlier we used to allow the public and students only on Friday because the interested people crowd is gone high. So we used to allow regularly from Monday to Saturday, morning 10 to 12 and afternoon 2 to 4 we are allowing it.
The observatory has evolved from its humble beginning to become one of the most important centers for solar studies in the world. The Kodaikanal Solar Observatory has provided several generations of astronomers and observers with requisite tools to understand and decode the mysteries of the sun.